Hello everybody, it's old SHAZIZZ here. I've successfully exchanged insanity for madness and fit a square peg into a round hole by sacrificing my comfy chair that's up there on the table for a wooden stool. If you saw my last video, Encroachment, you know that I'm looking for an attorney to sue my wife and kids. Anyway, this bit of madness that I'm fixing to bring to you, y'all happen to notice there. I'll try to move my camera in just a hair bit closer. If I can get through the square peg into the round hole. I'm sinking down here. I'm telling you, I'm going down with the ship, man. It's closing in on me. That might be just a hair too close. Okay, let's straighten this out just a hair. Alrighty then. So what you're looking at is a Samsung motor out of a direct drive washing machine. I showed this in the last video and I've showed it once or twice before, I think. Can't remember. Anyway, take note that there is absolutely no voltmeter involved in this situation because I want you to use scientific observation to see something that I'm wanting to show you with this video. So I don't have to argue with all the mathematicians out there about how much you're getting in as opposed to how much you're getting out. There's something important that I want you to see without having your mind clouded with math. Everybody knows everything about Lenz law and how if you induce a current in a magnetic field, you will create a second field that will be opposing the field that you're trying to use to generate. So with that said, the trick is trying to figure out ways by which to do an energy transfer to where you do not invoke Lenz's law. You're not trying to violate Lenz's law, you're just trying to ensure that you get to a point where you do not invoke Lenz's law. Now the first thing I want to draw your attention to is these little 110 heater fan motors that came out of a couple of those fireplace heaters that I tore apart because they didn't work anymore. The motors were good, there were parts in there I salvaged out of there. And these have a rotor motor in there that is really unique. If you get a chance to take a look, the only copper windings in this entire deal is two little copper loops right here. Let me float you through the air and make you dizzy and show you. Now these motors right here, the only copper in these entire deals right here in the actual rotor portion of it is these two copper loops. Of course, then you have your coil for your 110 AC. This is where you get your power to send the magnetic flux through to the motor, the rotor inside there. Anyway, back to the thing at hand. These really unique motors. You should take a look at how the rotor is actually built in there. It's not like the old rotors that were wound with coils or anything. These are like aluminum and iron mix of some sort, and they have little angular slots cut into them. And I believe that they're actually kind of designed like a, I can't remember the dude's name now. Anyway, he designed a specific rotor that would rotate like that, sideways, so that you wouldn't have to fight that back EMF. Alright, so what I wanted to show you here is, if you saw the last video, you know that this is a pretty good little generator right straight off the store shelf. Absolutely no modifications to this whatsoever, even to this point. And I'm running it off of one of the phases here, which in this case I'm just using the blue and the red wire off of this deal. But watch these motors right here. At a really low RPM, there's 3 of these motors. I'm hoping you can see that turn on there. Let me try to scoot the camera in there and get it a little bit better. Square peg and round hole. It's driving me nutty. Alright. I want you to be able to see my hand in the background turning this thing. so you can get a general idea how low the RPMs are. But you'll notice that all three of those are running, and I'm not having to fight to turn this rotor. Alright, there's a little bit of pressure on there because there's magnets surrounding the coils of wire, and you do get some sort of cogging, but not nearly as bad as you would on let's say that tungsten element light bulb right there, which is a 150 watt light bulb. Alright, so you can see I'm running three of these things, and they're all set in parallel with each other, and they're running just fine. Speed it up a little bit, but when you get past a certain RPM on this, those won't run anymore. The way that they're designed, the way that those rotors are built, they're slotted, and they're designed to basically synchronize for about 60 hertz. So they'll run good on your house. They'll run good on this on low RPMs, but when you speed it up, such as what I'm going to show you here in a bit, I'm going to use this drill right here, they won't come on. They'll come on at low RPMs, and will barely turn. Maybe one out of all of them will barely turn at high RPMs. So there's something going on there worth paying attention to. Alright, let's readjust here. This may end up being a long video. I might have to stop it a little bit and then reset and redo things. Okay, so we're going to take off from that right there, and we're going to wire right directly into this 150 watt light bulb. Just going to wrap this plug around there, and that plug around there. And for this incident, my prime mover is going to be a pair of vice grips. Alright, now I get a lot of resistance going on there. Alright, so I have to work hard at that. So what happens if I I'm going to steal my light from my lamp here, or my cord from my lamp, and I'm going to connect this here drill with my custom socket made to fit in the drill. And I'm going to have to hang on to this puppy because it's going to have a lot of torque right out of the gate, because since that's already connected, Lenz's law is already ready to go, man. So watch. You see that thing buck? Alright. Now we're going to do something totally unheard of. And I'm going to show you something cool. Alright. So in this instance, I'm using these fluorescent bulb starters that are no longer in their canister. If you look really close inside there, you'll see that there's a little thermal switch inside there. I hope you can see that. There's a little thermal switch. These have argon in them. Alright, and you always hear me talking about plasma. Plasma this, plasma that. And we're not talking about the Keshi style plasma. We're talking about where you energize a noble gas into the plasma state, which you see in your plasma globes and your neon bulbs and fluorescent bulbs, so on and so forth. And so, if I can find my clips, dead, burn it. Maybe I didn't bring them in. Alright, well, we'll just try it this way. We'll just try twisting them around. Okay. Let's get these out of the way so I don't break those. Now what we got going on here is we got 2 fluorescent bulb starters run in series with the power to the plug to the 110 watt or 150 watt light bulb. So what I want you to pay attention to on this, as soon as you see the purple in there, that energy is coming from that generator head to the plasma state. When that light bulb kicks on, it's because the thermal switch in there made a connection. The plasma heats up the gas, which the heat from the plasma heats up the element and closes the switch and turns that light bulb on. So I want you to see a difference, if you can see this, of how different it is. This drill is not bogging down from the start, but you already got plasma created into those bulbs. And then until you hit that switch inside, or until that switch heats up and hits, then this isn't going to have to work so hard to turn. So watch this. Now, do you see that? Let me dim some lights here. I want you to be able to see that plasma in them bulbs. You should be able to see it pretty good there. Alright, here we go. Plasma. The drill's not working hard. Did you see that? And you also notice that 150 watt light bulb was way brighter than it should have been. And I'm surprised it didn't blow itself out. Alright, we're going to rearrange a couple things. Alright, let me see my time on here. I'm going to pause this and then restart one here. Okay, sorry about that. I'm back for this deal right here. I've exchanged the little fluorescent bulb starters, which you saw there, and essentially replaced these little starters that have the, you can't see it, have the little thermal switch inside of them. That trying to get you a good view of that thermal switch. Trying to do everything backwards is a pain in the neck. Anyway, these have a little thermal switch. When the argon turns the plasma heats up the thermal switch, and it makes the circuit and turns on the light bulb. That's what you were seeing last time around. And so on this go, there is no thermal switch in there. Yeah, doggone it, can you even see the light bulb because of the light overhead? Alright, well, either way, what we got here is a fluorescent tube. It's blending in with everything because of the lighting around here. And you see that this has a dark spot right here. It's a bad bulb, won't work in your normal ballast. And all I'm going to do is use it to transfer energy from this generator through that tube and light up that light bulb. Okay, so the key to this right here is whenever you saw the last deal with the argon gas in there and the thermal switch, you also saw that whenever that thing kicked that thermal switch and Lenz law went into full effect, how much it bogged down. Now you'll notice a slight difference in this one. Not as much as it would be if that was completely filled with argon, but keep an eye out here. Alright, here we go. Now, I don't know, you gotta pay real close attention because it's white. Let me turn this doggone overhead light off. I want you to see that both lights come on. You have to probably pay real close attention because when that when that gas gets energized and makes a path for those electrons to go to that light bulb, it's the two lights are going to blend into together. So you'll have to watch. This should light up just a split second before that other light bulb comes on. Here we go again. Alright, we're going to have to try this a different way. I'm going to have to hide that light bulb. Let me see if I got something here to hide that light bulb with. How about a sack, Jack? We'll put this sack in the way. Alright. Now, you'll see the fluorescent light bulb, I hope. Okay, here we go. Yep, that was the fluorescent light bulb. Now this is both of them. Alright, now let's hide the fluorescent light bulb. We're playing a game called Hide the Light, man! I'm trying to sleep. Yo, yo, yo. Alright, folks. You'll notice that drill didn't have to work near as hard going through that doggone dead bulb there. And this is what the plasma research that I have going on is all about. Let me try something different here. I'm going to use this light. I can't because I got the power cord off of that light. Oh well. Alright. So essentially what you seen going on here, and I also wanted to show you before we get too far away from this, I want to unhook these lights, and I want to hook this up back to the electric motors that we started off with earlier, because I wanted to show you what was going on here, and it's a timing issue. It's not that it don't have enough energy to run it, it's the time. Because the way these are slotted on that rotor at low RPMs, gonna make a liar out of me. Where we at? No, I'm still going through that. Ta-da! Okay, there's one there. There's the blue one. Ah, there's the red one. Duh. Okay, now at low RPMs, I'm hoping you can see that. Let's stop it. Alright, see, none of them's turning. At low RPMs, they're all three turning. Okay, so when I put this up to some serious RPMs, they started off turning. As soon as that RPM drops down there, you see that thing kick on right there. Really low RPMs, and you got 3 electric fans blowing. So the key to this video right here, these anomalies that you're looking at, being able to run the energy through that old burnout bulb into that, you're energizing that gas, or some people say there ain't gas in there, there's just a vacuum and a coating in there. Either way, you're energizing material inside that vacuum, and you're allowing that energy to transfer through to that light bulb, reducing the Lenz effect when it's going in there. And I'm telling you, I believe if it's done right and you run it through any of the inert gases, noble gases, argon, neon, halogen, whatever, helium, and you could change that energy to a completely different state and pull it away from the load, from the generator head. That's what I've been trying to tell people, but some folks just get really seriously upset at me whenever I'm trying to tell them stuff sometimes. Yeah, there's those doggone clips I couldn't find. Alright, I'm going to try something here. I'm just going to attach those two bulbs on there. Ta-da! Apparently I need a better connection. Try this. Alright, well that's part of science, man. Ed burning, I got a bunch of tangled up wires, but you saw what I was trying to show you. Let me pause this and see if I can set that up again and show it to you. Alright, I'm back. Still got the same kind of deal going. I just put one less bulb on there. Apparently I got some short in some of these doggone little plugs. So let's try to see if I can get this before it shorts itself again. But essentially this is just that fluorescent light bulb alone. And if my calculations are correct, it's the material in the deal that once it does become conductive, you get some sort of lens effect. But you'll note that this drill is not bogging down like it would be on a dead short on this right here. Alright folks, that's been long enough. I guess hope you enjoyed the video. Hope you understand what it is that I'm trying to show you. This whole alternative energy thing. I'm showing you different things that if you use them wisely, at the very least you could have fans, lighting, off of nothing more than junk that you dug out of the recycling bin. If you take this to the extreme and actually get somebody to manufacture a generator, you'll note that these motors here work really good with AC. AC motors are really good motors. This is a DC motor that is actually run off of an AC circuit because it's a permanent magnet rotor and two-phase stator. Now imagine on the opposite side of that thing, if you got an AC motor on the opposite side helping to electrically assist this, so this doesn't have to work as hard whatever your prime mover is going to be. When this thing's turning, one of the phases is using the AC to assist the DC portion of the side over there. It's used to assist it via the shaft. So the only direct connection you have is from the electrical going out into that AC motor. And you're not going to get all the the lens effect like you would be for, I'd say, a regular DC motor. Let's take a real quick before I jump up off of here. And we're going to connect this back up. Just wire that in there like that. Alright, that's the red and blue wire off this thing. Now you'll notice that those motors are turning. So if you can visualize an AC motor on the opposite side of this. This is putting out pulse DC. When you're turning this motor, it's kind of hard to start turning at first. The faster you get it going, the easier it gets to turn. So if you're taking some of the energy off, like I'm doing right here, and turning this motor, and you got an AC motor built onto the opposite side of that, the faster you turn this, that energy on the other side will assist this generator head. And then you still have one more phase that you can draw off of. If it was done right and you used the energy, you pulled it away from the generator in the form of plasma, not the hoodoo voodoo version of the plasma, like I ain't even going to say it anymore. The plasma that you saw in these argon filled tubes. You can see that when it was in the plasma state, it didn't run that light bulb until that plasma heated up that element and turned that element on and created the circuit. But what you should have noticed in that is that in the plasma state, you didn't have the back EMF. There was absolutely no drag on the prime mover, which was the drill that we were using during the plasma state. In the plasma state, you have just as much energy as you did with this. Whatever this can put out, you can create plasma with and turn that energy. You can take that energy away from this. If you could visualize a glass tube, inside this glass tube had some copper tubing all the way through it. No electrical connections to the copper tubing itself. All you have is a heating element, or not a heating element, a connection from each side that was inside that plasma, or inside that gas. When you shoot the high voltage AC in, it's going to energize that gas into the plasma state. The higher the AC current comes in, you can need to energize it with DC, just high voltage. The higher the voltage gets in there, the hotter that plasma will become. It will heat up the copper tubing, and whatever you circulate through that copper coil inside there, you take the energy from this away in the form of heat and never at any time create any back EMF that will bog this generator down. Okay, that's about it. So with that said, everybody, fitting a square peg into a round hole. That's SHAZIZZ mad science for you. And somebody saved me from my family and their storage problems. All right, take care, everybody. I got to get back in my lab. Peace and love.